Hello again. I think I'm going to start by going over last night's homework first, and then I'll get into the warm-up question after that. Last night's homework looked really good as always. I just wanted to go over the graphs because those are always a struggle for people. Some of you got them totally right, so great job if you did, but I think it will help all of you to hear an explanation of those again. So grab your homework from last night, Unit 13, Day 10, and flip over to the back. And I want to do these two graphs. So it says sketch a graph of the following functions for one full cycle. That's the key. And you're going to see today there's going to be some times when that instruction is a little bit different, but that means you're graphing one period of it. And yesterday, we only talked about amplitude and period. We talked about frequency too, but frequency and period are kind of the same thing. So I would list those values out. You all did really well on these questions where it asks you to state the amplitude, frequency, period, and range. Do that with these ones also. So like with number 8, what's the amplitude? Amplitude, remember, is always the absolute value of the number out front, so the amplitude's 3. Frequency we can talk about. What is it? 2. It's the b value, the number in front of the x. But what's going to help us more is period, because we want one cycle, and that's what a period means. So how do you find period? Right, remember 2 pi over b, and since b is 2, 2 pi over 2 is just pi. Okay, so then before you go down here and start graphing, think about what a regular sine graph looks like, because it all hinges on that. So normally with sine, we go 0, we go up to 1, back to 0, down to -1, back to 0. That's one cycle. That's essentially what your graph should look like, because I'm asking you to graph one cycle. I didn't ask you to specifically graph between 0 and pi over 2, or 2 pi. I asked for one cycle. So what I would do is I would make some axes and then just graph one cycle. Here, let me try to get straighter axes there. Okay. Okay, so just graph one cycle. The other thing you want to think about is the amplitude is 3. This is a regular sine graph, so where do I start? So you should have a dot right here at 0. And then you can, I don't know, go every 3, go every 2, whatever you want to do to space it out. Instead of going up to 1, we're going up to 3. That's what the amplitude does. So go 1, 2, 3, put a dot up there. Then go, just stay consistent with your spacing. So I'm going every 3. If you did something different, that's fine. So here, I should be back to 0. Then go every 3 again. Here I should be down, but not down at -1, down at -3 because of the amplitude. So right there. And then I'm going to end back at 0. So when you connect your graph, you should see a regular one cycle of sine because there's no reflection happening here. The only thing that's changing is the amplitude goes up to 3 and down to -3. Now where period and this frequency stuff comes into play is the scale. The end of the cycle is supposed to be pi. So you just take that number and put that right there. That's pi. Now technically this is pi over 2. You can label that 2 if you want. You don't have to, but the halfway point is usually pretty easy to figure out. And you don't have to label the y scale if you didn't change it. So if there's no numbers listed, you can assume that's 3 and -3. If you want to put it on there just for good measure, it's not terrible. But that's what your first graph should have looked like. Okay, so now do the same thing with this one. What's the amplitude? All right, it's 2, not -2, because amplitude's always positive. Well, what is the negative going to affect? There's going to be a reflection. So I would just circle it, write a note to yourself that you need to reflect it. What's the frequency? 1/3. And what's the period? It's 2 pi over 1/3. So it's a complex fraction. You're going to multiply top and bottom by 3. You're going to get 6 pi. So again, you want to think of what the regular cosine graph looks like. Where does cosine normally begin? It normally starts up at 1, and it goes down to 0, -1, 0, and ends at 1. That's regular cosine, and it's important that you know what that parent function looks like in order to do your graph. Okay, so I'm going to make some axes again. And there's a couple differences. So for one thing, if this was just +2 cosine, I would be starting up at 2 instead of up at 1. But it's -2 cosine. So even more than that, instead of starting up at 2, I start down here at -2. Then I'm just going to go every 3 again. So this spot is going to be 0. Go every 3 again. Now I'm going to be up at 2 because I'm reflecting it. Now I'm going to be back at 0. I'm going to end down at -2. Okay, and the graph should kind of bend like this. Some of you had the shape off a little bit, and I said I'd go over that. So it should look like a top of a mountain or something. All right, that's what your graph should look like. Now again, period comes into play when you're doing your labels. Put a 6 pi right there, because it should be one cycle. I graphed one cycle that ends at whatever the length of the period is. So right here is going to be 3 pi. And if you wanted to label this as 1.5 pi and 4.5 pi, that's fine. You don't have to. And again, you don't have to label this as 2 and -2 because the scale is going up by ones. So that's what it's assumed to be. But you can. So I think some of you were getting confused with frequency. Frequency is just how many cycles there would be between 0 and 2 pi. So this one's kind of easy to see. If I had gone to 2 pi, there'd be another cycle. I didn't because the graph only asked for one cycle. Here, where's 2 pi? Well, that'd be somewhere around here, which is not quite half a cycle. You could believe that it's a third of a cycle if you look between 0 and 2 pi. But I didn't want between 0 and 2 pi. I wanted one full cycle. So I have one full graph. Now, sometimes I will say specifically a range or a domain to graph in, and you'll see that in notes today. But most of the time, you'll see one full cycle, and that's how to do it. Good? All right, I also told people that I would show them how to check them on the calculator again. If you wanted to check that number 8 was right, just go to y equals, type in 3 sine of 2x, and set your window up like the window you have here. So we need to stay in radian mode, because we're all in terms of pi's right now. So my x should go from 0 to pi. So I'm going to change this to pi. And my y's can go from -3 to 3 if you want. It's all about setting up the window and then seeing if when you hit graph, you get that one full cycle in that window. And you do. And they'll remind you if you need to reflect. This one wasn't reflected. So what would you do for this one? Same idea. Go to y equals, plug in the equation. It's going to be -2 cosine of 1/3 x. Make the window go from 0 to what? 6 pi. And y's can go from -2 to 2. That's our range. Hit graph, and if you see this one cycle, it should be an upside down because it's a reflected cosine. And you know you got it right. Good? All right, we'll do a little bit more graphing practice today, but hopefully that cleared some things up. The other thing I wanted to talk quickly about was this one down here, number 11. You always want to look at if you can find one cycle. So starting at 0, this one starts similar to the graph we just drew, below the x-axis. So the cycle ends right here. Now pretty much everyone got the amplitude. We're doing max minus min divided by 2. I like that I saw that in so many papers. The max is 1/3. The min is -1/3 divided by 2. Now some of you got stuck here. This is 2/3 divided by 2. If you think of it as a complex fraction, you can multiply top and bottom by 3. And you get 2/6, which is 1/3. That's the amplitude. Now it does have to be negative in the equation because it's reflected. So it's going to start with y equals negative 1/3. Is it sine or cosine? It's cosine. You can tell that because it doesn't start on the midline. But then a couple of you got confused on how to find the b value. A period is not 5 pi over 2, just because that's where the graph goes. The period is where this cycle ends, and if the cycle started at negative 1/3, it ends at negative 1/3. So the cycle is 2 pi, which means period is 2 pi equals 2 pi over b. And if you cross multiply, you'll see that b has to be 1. So that's why it's just negative 1/3 cosine of x for your answer. All right, if you had any other questions, I tried to answer them in your email, so check that. Now let's go over to today's notes. We're going to start with a warm-up. So based off of what we just talked about, see if you can do number 1 and 2. And pause the video for a second and press play when you're ready to see the answers. Don't get lazy. If you haven't paused it, paused it. But if you did and you tried it, here's the answers. Amplitude is always the absolute value of A, which in this case is absolute value of -2. So the amplitude is 2. Remember, the amplitude is always positive because we're talking about how far it's stretched. Frequency is the number in front of the x. The b value, in this case it's pi. Which doesn't really mean a lot. That just means there's pi amount of curves between 0 and 2 pi. Period is the length of one cycle, so do 2 pi over b. And what's 2 pi over pi going to be? Just 2. So this cycle will end at 2. If I was graphing one cycle, the last point would be 2 on the x-axis. And yesterday, the only thing that affected the range was that amplitude. So instead of being -1 to 1, it's going to be -2 to 2. There's going to be more affecting the range today. Okay, for the graph, lots going on here. Let's start at 0 and see where one cycle is. I start at 0, I go up, I come down, and I end again. That's one cycle. Okay, so when you're trying to figure out the equation, first off, does that look like sine or cosine? It's sine because it starts on the midline. What's the amplitude? There's two ways to do it. How far above and below the midline does it go? It's 3. Or you can do max minus min divided by 2. So 6 over 2 is 3. Does it need to be reflected? Not this time, because sign goes up first normally, and this one does too, so it's a positive sign. The only other thing we need to find right now is b, and I can't tell how many cycles there are between 0 and 2 pi, because I don't even know where 2 pi is. It's not on this graph. So use the period. The length of this cycle is all about what number was at the end here. And I kind of went over it with my line, but it's 1. So period equals 1. Set that equal to 2 pi over b. So if you multiply, you're going to get that b is 2 pi. So your equation is y equals, I'm glad you all remembered that. Didn't see any missing y equals on the homework. 3 sine of 2 pi x. All right, so hopefully you feel okay about that. Today we're going to be talking about the other two big features on a graph, which are midline and phase shift. So here's those notes. If you were able to print those out, great, start filling these in. If not, just take some notes on a separate sheet of paper. So like I said, we've talked about the effects of A and B on the graph. Today we're talking about C and D. And we'll start with D, the number added onto the end. So consider the function f of x equals sine of x plus 3. There it is. Or sorry, how would the graph of y equals sine of x be shifted to produce the graph of f of x? This is the graph of sine of x. You can see normally I make one cycle. You can tell that's sine right here. Here I decide to go to -2 pi also. But we know it goes on and on forever. So if I just think transformation-wise, if I have a +3 after sine of x, is that going to affect the x's or the y's? It's going to affect the y's because it's not directly attached to the x. So it's going to push it up 3. So this would be a translate, oops. This would be a translate up 3. So it says on the grid to the right, that's the basic sine curve. On the same grid, sketch the graph of f of x. We just got to take every point and go up 3. So 1, 2, 3. I'm going to go here, 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 just all the way through, moving every point up 3. So there's the new graph. And that would be sine of x plus 3. On the graph you sketched in part B, draw the horizontal line that splits the graph in half. What is the equation of this line? So the x-axis split the original graph in half. If I move that up 3, there's the horizontal line that splits this one in half. Half of it's above, half of it's below. What's that equation? It's a horizontal line, so it's y equals, and it's y equals 3. So that equation of that line we just drew in part C, we've seen that before. What's that called? It's called the midline. And as you saw in one of the homeworks, sometimes it's called wrap line. I usually call it midline, but sometimes you'll see wrap line written also. Midline because it's the middle of the graph, it splits it in half. Wrap line because the curve kind of wraps around it. It's always equal to the vertical translation, which we talked about a couple days ago. So if it's shifting up and down, that's going to have a new midline. But make it an equation always. So even though the translation's 3, the midline's not 3, it's y equals 3, because it's got to be an equation. It's also referred to sometimes the average value of the function. So I've got 3 names for it: midline, wrap line, average value, 4 if you count vertical translation. But if you think of it as the average of the graph, it's easier to figure out how to find it. If you don't have the equation already, and you can't tell where it is just by looking at the graph, it's similar to amplitude. But instead of max minus min divided by 2, it's max plus min divided by 2. You're literally finding the average. So don't confuse that with amplitude, which is a minus here. Okay, so if I give you f of x equals 2 cosine of x plus 1, I mean the amplitude, frequency, and period. This is review from yesterday. What's the amplitude? It's 2, because the absolute value of 2 is just 2. What's the frequency? It's the b value, and it's 1x right there, so that's why it's 1. And period, it's 2 pi over b, which is 1, so the period is 2 pi. New piece today, what's the midline? Well, this has a vertical translation up 1, so we're shifting up 1, so the midline is not 1, it's y equals 1, it's a midline, it needs to be the equation. Okay, sketch the graph of this function over the interval from negative 2 pi to 2 pi. So this isn't technically asking me for one cycle. It's asking me for a specific domain, which is what I mentioned when we were going over the homework. So if I label these, this needs to be 2 pi, and this needs to be negative 2 pi, because that's the extremes of my domain. So what else is going to this? This is going to be pi. So this will be negative pi. This will be pi over 2, negative pi over 2, 3 pi over 2, negative 3 pi over 2. Okay, so like when we were graphing on the homework, think about what the normal parent looks like. The parent here is just cosine. Where does cosine normally begin? It starts at 1, then it goes to 0, negative 1, 0, and 1. That's the normal cosine graph. So even though this doesn't ask for one cycle, I would kind of start by just graphing one cycle. Now the extra piece of this is we have a midline. Draw in that midline. So draw the midline first, because that's where we're measuring everything from. Now if I know the amplitude is 2, and this is just positive cosine, not negative, so it's not reflected. If I'm starting here, where cosine normally starts, I'm going to go 2 above the midline. So I don't go up to 2, I go 2 above the midline. And then the next point is on the midline. And this point will be 2 below the midline, so really down at -1. This is on the midline again, and this is 2 above. So if the directions said graph 1 cycle, this would be your answer, like on the homework. But now use that 1 cycle to do the domain they want. If I go over here to -2 pi, what's going to happen? It's going to be the exact same shape, right? Because it's another full cycle. So whether it gives you a domain or the directions say graph for 1 full cycle, always start by graphing a full cycle. After that, you can adjust to whatever domain you need to do. Last question here, what's the range of this graph? What's the lowest it gets? -1. The highest it gets is 3. And you can see that from the graph, but how could you have gotten it just from the equation? Well, yesterday we would have said the range was -2 to 2 because of that amplitude. But now everything's getting shifted up 1. That also affects the range. So I would also do a +1 on both of these. -2 plus 1 is -1. 2 plus 1 is 3. So now you can get it with an equation, or you can get it by looking at the graph. All right, next page. So that vertical translation affects the range of sinusoidal graphs. Again, sinusoidal could mean sine or cosine. It's a little misleading. So here I just want to figure out amplitude, frequency, period from yesterday. I added midline into it, and then remember midline will affect the range now also. So if I start with y equals 7 sine of 2x plus 4, what's the amplitude? Absolute value of a, which is the absolute value of 7, so just 7. What's the frequency? It's the b value, which is the number in front of the x, so 2. 2 cycles between 0 and 2 pi. What's the period? 2 pi over b. So 2 pi over 2 is pi. So 1 cycle will be done by the time I get to pi, which makes sense because there's 2 cycles between 0 and 2 pi. New piece today, what's the midline? Midline is the vertical translation. This is going up 4. So it's y equals 4. I don't want to see any midlines of 4. It needs to be y equals 4. And finally, for the range, it's the amplitude, which would be -7 to 7, plus the midline. So that's going to end up being -3 to 11. So that's why it's helpful to be able to do it without a graph, because here we don't have a graph. All right, if you want to try finding all of them in 2, press pause and give it a shot. If you're still a little shaky on it and want me to go over it, amplitude would be absolute value of -5, which is 5. Frequency is pi over 3. Period is 2 pi over b, so 2 pi over 3. You'd have to multiply top and bottom by 3 here. So it's 6 pi over pi, or just 6. So 1 cycle would end when the x value is 6. Midline, it's going down 6. So it makes it y equals -6. And range. Start with your amplitude. So that's going to make you go from -5 to 5. But then I'm going down 6. So it's -11 to -1. Okay, so that's how you pick out all those values from a graph, or from an equation. Let's do another graph. Sketch the graph of -3 cosine of 2x plus 1 for 1 complete cycle, just like the homework on the grid below. Even though it doesn't say it, find all of these things first. It will help you. So what's the amplitude? It's 3. But what's the negative going to cause? A reflection. So maybe circle that at this point. Right, reflect. Frequency is 2. So if I went from 0 to 2 pi, we'd see 2 cycles. I only want 1 cycle. So what helps me more is the period. 2 pi over b, 2 pi over 2 is pi. That's going to be important. Midline, new piece of today, is y equals 1, because we're going up 1. And the range, although it's not going to really help us graph it, it'll help to make sure your graph is right at the end. What would the range be? Well, we go from -3 to 3, but then we're bumping up 1. So we'll end from -2 to 4. So your final graph should go between -2 and 4. Okay. Now when we're ready to graph, you need to think of what 1 cycle of cosine, because that's what we're graphing, normally looks like. Where does cosine normally start? On the midline, above the midline, or below? It normally starts above. Then it goes on the midline, below the midline, on the midline, and ends above again. There's 1 cycle of regular cosine. Okay, so then come over here, make your axes, and you always want to draw the midline first. That's the new piece today. So go to y equals 1 and draw in a midline. Now use your parent graph. You have 5 points. So if you're doing 1 cycle, you should have 5 points again. The amplitude is 3 and it's being reflected. So instead of going 3 above the midline to start, we're going to start 3 below the midline. So 1, 2, 3, we're going to start right here. And then I'm going to go every 3 again. My next spot, so I've done this one. My next one is on the midline, right there. So 1, 2, 3 again. Normally I'm below the midline. Here, since I'm reflecting, I'm going to be 3 above the midline. So right here, I've done that one. Then I'm back to on the midline. That's that point. I'm going to end 3 below the midline. And you got to have that curvy shape to it still. And just double check. I'm going from -2 to 4, so that looks good. What should this spot here be labeled? That's the end of 1 cycle, which is the period. So this needs to be labeled as pi. If you want to do the midpoint, that'd be pi over 2. Okay, so hopefully graphs are starting to seem a little bit better. I would still encourage you to graph it. So -3 cosine of 2x plus 1. Your window's going from 0 to pi, because we wanted 1 cycle. So 0 to pi. The y min is -2. The y max is 4. And if you did it right, you should see that same shape that you just drew come up on the graph, and nothing more. If you see it, you can confirm that you did it right. So that's how you should check it tonight. All right. Let's do an equation. Determine an equation for the graph below. Like I've been saying all day, like with the graphs, draw the midline. Now you might be able to eyeball where the midline is here. If you can't, remember you can always do, it's the average. So instead of max minus min divided by 2, it's max plus min divided by 2. The maximum, it looks like it's hitting, is 3. The minimum is -1 divided by 2. So that's 2 over 2, or 1. And that's probably what you would have eyeballed if you were guessing on the midline. Okay, so now starting at 0, trace out one cycle. What type of graph does that look like? Well, it starts on the midline, but it goes down first. So this is going to be a negative sine graph. You can get the amplitude either by doing max minus min divided by 2, or you can look at how far down and how far up from the midline do you go. This goes up to 3 and down to -1, so that's a distance of 2. So the amplitude is 2. Or again, you can do max minus min divided by 2 if you prefer. So 3 minus -1 divided by 2 is 4 over 2, which is how the amplitude becomes 2. There's one cycle. So you can get b in two ways in this one. How many cycles are there between 0 and 2 pi? There's 1. So b is 1. If you'd rather look at it in terms of period, because you can't always use this, the period is 2 pi, because one cycle ends at 2 pi. So set that equal to 2 pi over b, and when you cross multiply, you're going to get 2 pi b equals 2 pi. So obviously b is 1. So if I was just doing this like yesterday, it'd be y equals what's out front. It's a negative sine with an amplitude of 2. So -2 sine of b is 1. So you can write 1x or just x. That's where we would have stopped yesterday. But now also account for this midline. What needs to be on the end? Plus 1. Because the midline is 1. If you wanted to, you could check these answers too. You can always plug that into y1 and then set up your window like this and see if it matches. That's how you do that one. All right, almost done. Last thing we need to briefly talk about is phase shift. And phase shift is essentially a fancy word for horizontal translation. In that original equation that I had with all the letters, it'd be the C value. So for this last example, I'm just going to show you what phase shift does. We've got two equations that are almost the same. What's the amplitude for both of these? Absolute value of 3, so just 3. What's the frequency for both of them? It's always the number multiplied in front of the x. Even though this one's factored out with a parenthesis, it would be 2. So the frequency is 2 in both cases. What's the period in both cases? Well, period's still 2 pi over b. We just said b was 2. Period is pi. So you're going to make a distance of pi for one cycle. What's the midline for both of them? Again, be careful of saying 1. It's not 1, it's up 1. So it's y equals 1. Here's the new part, phase shift. Phase shift is the horizontal translation. Now there's nothing in with the x being added or subtracted on f of x. So for f of x, the phase shift is 0, because you're not adding or subtracting anything. But for g of x, we have this minus pi over 2 part. Which way is that going to shift it, left or right? It's going to go right, because remember, left and right are backwards. Minus is right, positive is left. So this is going right pi over 2, which means that the phase shift is pi over 2. And I'll show you what that means on a graph in a second. So sketch both graphs of f of x and g of x on the grid below. Okay, this one kind of gives me a set domain again. Let's start with graphing one cycle. So these are both sine graphs. So picture sine normally starts on the midline, then it goes above, back to on the midline, below, and ends on the midline. So that's regular sine. Picture that. Neither of these are reflected. So let's do f of x first. I'll do f of x in blue. So graph one cycle. One cycle goes from 0 to pi. So the midline is 1. So I'm going to do that in black. Here's the midline. The equation is 3 sine of 2x plus 1. So I just took care of the plus 1. I need to go up 3. But since it's sine, it starts on the midline. Now be careful with your period. The period's pi. So one cycle is going to end here. So if I wanted to end my cycle at pi, that's the start point, that's the end point. Those are the 2 points I've plotted so far. The middle point will be right here. And here I have to go above the midline, here I have to go below the midline. So halfway between here and here, I need to go 3 above the midline and 3 below the midline. So there's one cycle of f of x. Period is pi, because the cycle's ending by the time I get to pi. Now if I wanted to go to 2 pi, what would happen? That same thing. And that's where you can see what frequency is. Between 0 and 2 pi, we had 2 cycles. Same type of thing is going to happen over here. So now that I know the left side, or the right side, I can come in and draw the left side. There's another cycle. There's another cycle. So when they give you a specific domain, start with that one cycle and go from there. That's f of x. Now finally, g of x is the exact same graph, except it's shifting right pi over 2. So let me do in red g of x. Actually, I should label these. So the blue one is f of x. Red is g of x. So I'm going to take all of these original cycle. Let's just start with this first cycle here. I'm going to move every point right pi over 2. So this first point here is going to go here. This point comes up here. This original midpoint is now here. This point comes over here. And this original endpoint ends right here. So there's my initial cycle. And the phase shift is called pi over 2 because instead of starting at 0, this cycle starts to the right at pi over 2. That's what phase shift does. So if I just keep following this pattern through, it would look like that. I continually going down, midline, above, midline, down, midline, above, midline, down, midline. So it looks kind of like a crazy graph with them both graphed together, but that's g of x. It's like a DNA thing from science or something. All right, so phase shift isn't going to be a huge deal this year. I'm actually not going to have you graph phase shifts generally. I just need you to recognize that if there's a horizontal shift left or right, it is a phase shift. That's the goal. All right, that is it. Give the homework a shot. Let me know if you have any issues. I'm still happy to meet with you if you want, so just let me know. Good luck.